previous video in the garage, we went over the installation of the oil cooler on this 1977 MGB with a chrome bumper conversion. One of the things that we did when we installed the grill on this chrome bumper conversion, we bought a little aftermarket grill. This aftermarket grill has kind of a diamond plate pattern instead of the vertical patterns that you see in the 60s series with the grill. So it's a little different. It varies from a typical design. But what we're covering today is how I made these grill plates to cover the oil cooler. You can see the oil cooler up in there. There's the oil cooler. We want to protect that from rocks and flying debris from when you're driving around on the country roads and whatnot. And so we built these little 3D printed, actually, these grill plates. So what we're going to go over in the video today is how I made these and how you can easily reproduce them. One of the real advantages to 3D printing is the community of people who share their designs online. So I'm going to share these online for y'all. You'll see a link in the description if you're interested in 3D printing, or if you want to see the 3D model that I used to create these. You're more than welcome to download those. It's part of sharing, it's just like the MG community, everybody's sharing their knowledge. The 3D printing community also has a very similar knowledge sharing interface, and I'll show you a couple of different ways that you can get that information. But let's go ahead and go through the process of what it took for me to model this in real space and then put it into virtual space, and then get the new designs out into the real world from a 3D model. So let's get started. All right, so as with so many fabrication projects, the first place to start is to identify the actual location and the dimensions of the place that you're trying to fabricate a solution for. So where you start with most of these projects is a piece of cardboard. And what I did in this case is I cut out a piece of cardboard that looked similar in size and shape, and I put it in the back. I laid it into the back. Whoops, fingers out of the camera. And I drew, you can see I drew some lines to give me some shape, and I'm able to take that and take that to the workbench. And once you have the shape laid out, you can see oops, it's upside down. Yeah, okay. So once I had the shape laid out, you can see there's a curve on the top, and actually that curve is on the bottom, but it doesn't matter. It's straight on the top and curved on the bottom. But what you'll notice is that it's different. It's a different thickness here than it is here. So it does have a bit of deflection right in here. This is an irregular shape. It's not just a straight line. So when I drew the line, I took measurements at intervals to get an idea of what the actual curve was going to be on this bottom half, right? And what the actual measurements were of the inside and of the outside, so we can get an idea of how thick that bezel needed to be. So once I have all those measurements, you can take that from there and go into the 3D modeling software. I used Onshape, which is a free online thing. It's a really great resource. They have an ability, if you're a hobbyist, to log in and create a free account and share designs from all over the place, and then make your own designs and share those as well. So it really is a great community of designers. So let's get onto the computer and I'll show you what Onshape looks like and how I was able to create a model from this cardboard cutout. The program that I used to 3D model the oil cooler grills is a program called Onshape. It's an online resource. You don't have to install any software. It's all completely web driven. So any browser can work with this. Go to onshape.com and it will resolve your local area and language. And normally this is a paid resource. You have to pay for a subscription. But they have a thing here where if you click on request a trial on this page right here, they have a section for registering if you're a hobbyist. Like that, I'm a hobbyer, so that's the thing with me. You can sign up here, and then they'll get you a free Onshape account. Once you have your free account, you'll see this user interface right here. One of the things that you might notice on here, there's a lot of parts that are available in the public section for you to open up and import into your own area to play with. But one thing I want to point out real quick here is there is a number of things in here for MGBs. Here you have parts, there's some toys, there's a gear lever bushing. This is a fuel sending unit clamping retainer. There's there's little parts and pieces that you might have need of in your MG. Here's a seatbelt holder. There's some other parts. Anyway, you can browse through here and find all different kind of parts for the MG that you can print out in your 3D printer, and move forward with that. And you'll be able to see my part in here. Here is the part that I created, the MGB oil cooler. So let's break this down. How it was that I made this, and although it looks like it's a very complicated part, a lot of pieces and whatnot, it's actually a lot simpler than it looks. There's really only 3 components if you break it down into their constituent parts, and so let's go through that. So the first part here, let me take some of these and turn some of these parts off to simplify. And we're just going to focus on the first part here. The very first thing that I did when we were working with the cardboard was I took a bunch of measurements, and this is where we're at right here. And you can see this is the original design of that. It's just a 2-dimensional image. You draw the pictures with the interface here, you can see down here, this is the curved section. This is just a polyline, and the 2 dimensions are offset using. There's an offset command up here where you can make an offset. So you only have to draw the picture one time, and then you have the offset. So I mean that's incredibly easy. Just draw a picture, right? The next thing that you do is you extrude this picture. So when you hover over any of these lines, you can see any polygon that's closed, it turns into a face, right? And so here's the face between those 2 offset pieces. And if you click on that, you can see it makes a one big face. Any of these faces you can click on to extrude, and you extrude it. In this case, you extrude this and make the bezel, and that's what the first part was, this extrusion right here. You can see that. Real easy to make that. Wasn't that difficult at all. So then one of the other things that you notice in here is that this extrusion has curved edges. And the way that you do that is you pick what was a normal shape with square edges, and you can do a fillet. So it has a feature for that. So I didn't have to go through and make all those. I just extruded it. I picked the fillet and I made a fillet, and boom, there the bezels are done. That really wasn't that difficult. Now what you might be looking at that looks difficult is this next section. That's all these little diamond points. And again, you start with a sketch, and then you pick a face. In this case, the polygon face of the inside. Gotta get to where you can see that. anyway, and then you extrude it, and that becomes your extrusion. So one of the other things that you might notice on here is that's kind of tedious to draw all these lines. Well, actually, all I ever drew was one square. When you draw the one square, then you can use this linear pattern thing, and that little tool will make an array going in one direction and then another array going in the other direction of those squares, and boom, Bob's your uncle, you have it done. So it really was not that difficult to lay these out. Once you have one of them, then everything kind of falls into place. You extrude the pieces, and then they all come into play. The only thing you have to do is make sure that there's space to make sure that these are connected in printing. In this case, you can see I have a little bit of an offset here so that it ensures that this piece will be connected to the bezel. If you put things right to the corner, they'll actually print out as two separate pieces. It's kind of an oddball thing, but there you go. That is how I created this 3D model. Once you get the 3D model that you want, all you have to do is select the model. It picks all the faces. You right click on it and you tell it to export. And that will create an STL file that you can put into your slicer program. The slicer is a program that comes with a 3D printer, and it's basically a program that does the tool path for laying out all of the 3D extrusions. So I'm not going to go into that because we're not going to. This isn't all about a tutorial for 3D printing. That's a whole nother topic. But I just kind of wanted to highlight what it takes and how easy it is to 3D model parts and the practicality of 3D printing parts for your car. While we're in here talking on the computer about 3D modeling. There's a really great resource available on the web called Thingiverse. Thingiverse is a site where you can put in a search, and it's an online resource where people share their models for printing. And so I put MGB into the search here, and so you can see there's little models that people have printed out for different things for their MG. This is, just some. Here's a handle for the door. Here's a knob for the overdrive shift lever. It's the sky's the limit. Anything you can think of that you might want on your MG, there's a thing for it here in the Thingiverse. Here you can see somebody's printed an overdrive button for the dashboard. So anyway. Check out the resources, and you might be something that you're interested in. I have not yet spent over $200 on any of my 3D printing printers or materials, and I've more than recouped the cost on things that I've created that were difficult to find. So yeah, check it out. 3D printing for your car. Let's get on back to the car. All right, so once you do your model, the first thing you want to do is you want to start and do some prototyping. Prototyping is important. You don't just you can really never take what you have in a 3D model and print it out and expect it to be 100% correct the first time that you put it in there. Measurements can be different. In this case, maybe the mirroring between one side or the other was off or whatever. And in my case, the arch that I used for the rounded edges, I estimated that incorrectly. But you'll see in a second how prototyping really helps you to save a little bit of time. So when you're doing 3D printing, one of the biggest drawbacks with 3D printing, it's really a great resource. It's a lot of fun to play with. But every time that you print something, it takes hours to print it. It takes a long time. Even with a really expensive printer, they take a long time for layers upon layers of 3D material to be stacked into the three-dimensional shape that you're printing out. And so what you end up doing when you're prototyping is you don't want to print the whole design out. And so what I did is I created pieces of the finished product in sections. And here is an example of one of those pieces. What I did here was I made the bezel just to confirm that this radius that I had put in the design was correct. And it was a really good thing that I did that. Actually, I was starting over here. Is the radius, whoops, hang on. The radius turned out to be absolutely incorrect. This is a 3/4 inch radius, and it ended up needing a 1/2 inch radius in order to make this match up. You can see how wide this is. It really doesn't match. Prototyping saved me a whole lot of time printing out an entire big model and then having to change it and go back and make revisions. One of the other cool things about Onshape is that you can take your model and change one dimension and the whole three-dimensional shape will adjust itself to that dimension that you have. So it's not like you have to start all over again from scratch. It's a completely automated system. And all I did was I told it change the radiuses from 3/4 to 1/2. And it did make some inflection changes, but because I had the measurements, I was able to pull this back down because, 3/4 inch from here, once you make it a 1/2 inch, it stretched it up. So I was able to pull it back down, and the whole thing was easily adjustable. So that was one prototype that I made, and then the other prototype was the how to fit the grill that would fit on the inside part. And so I made this little lattice work. This is the first prototype, and I wanted to see what this looked like. Whether it fit in the hole, because this is going to fit in the void. The bezel goes on the outside, and this fits in the void. Well, I wanted to make sure that this lattice would fit into this section and that it looked good next to the grill. And in this case, you can see the thickness was way off, and I didn't like that. And so I was able to make an adjustment based on this prototype to come up with what ultimately ended up being the finished product. And that is this right here. See how that's a lot thinner of a grill? And it's almost undiscernible from the pattern that is in the store-bought grill up there. So the method that these things use to connect is have an overhang at the edge there, and that makes the bezel connect. And then this lattice work, what I intend to do is put a hole on the corners, one of these corner pieces, and then just put a zip tie in there. They fit in there nice and snug. They fit nice and snug in there. All you need to do is create something on the back that will keep them from falling forward. I think what I'm going to do when I do the finish installation on these is also add a little bit of black silicone sealer just to keep them from rattling. They're not going to have any screws or anything holding them on. It's just going to be interference fit and the little zip tie in the back to keep them from falling forward. But having a little bit of silicone in there will keep them from rattling a little. So yeah, and here you can see this is the 1/2 inch versus the prototype that had the 3/4 inch. See how that radius is a little different. So prototyping is really important, and then you mirror it, and then you set the other one up in there, and that will go right up in here. That is how that is done. Come on, get in there. Well, it's kind of a two-hand job. Anyway, you see the idea. All right, so let's summarize. The way that we did this first was we used the old cardboard trick, do a little cutout, get something in 3D space that's real easy to mess with. when you're buying parts from Moss, make sure you keep those cardboard boxes. They're really great for spray painting boxes. They're good for sending stuff to your kid in college. Keep those boxes because they're also good for cutting out cardboard for prototyping these little fabrication projects. So you take the cardboard cutout and then you get some measurements, transcribe those into the 3D software. We used Onshape for the 3D modeling, and then we used Creality's slicer to create the model that went ultimately to the Ender 3 3D printer. So once we had all that together, then we were able to put these in here, and everything works really great. So if you have any questions at all about 3D printing or fabrication on classic cars, sure, throw it in the comments. I'd love to have the interaction. If you have any questions at all about anything that I'm working on or have any suggestions for any future videos, please leave those in the comments. I'd be glad to check them out and see what we can get done. So that's all I have for you on this video. Check back soon. We're going to be working on the interior and getting that ready to go for its first drive once the weather cools down here, and we'll get some nice driving out in the country roads here in Texas in the fall. Cheers!